Hello everybody, today we are going to be talking about math in transportation, and this is from the Massachusetts Math Modeling Jam team. So let's begin with what is math modeling. So math modeling in essence brings math, which is equations, geometry, into the real world. So math modelers look at the trends and the patterns in the real world, from the spread of a disease to determining if improving profit would occur by placing an object at a specific part of the store, or choosing which posts should be put on social media to engage the most users. And math modelers look at these trends and the patterns to offer solutions to these problems. And so one aspect of math modeling is transportation. And so some of the big questions in transportation is, how do we schedule plane takeoffs and landing so that both the time and the fuel usage is minimized? How many trucks do you need so that every shipment between a network of locations will arrive on time? And how do we optimize the positions of train stations to maximize the profit? And the last bullet point is what we're going to be talking about today. And so math has a very wide role in the field of transportation. To begin with, the trains you ride and the planes you fly don't just travel from point A to point B without math modeling. That is because each trip is specifically designed, carefully designed, to ensure the route, staffing, and the timetables and any other key functionality is done in a way to reduce waste and increase and maximize the profits. So how do you know that math is used in transportation jobs, like being a pilot or managing a highway system? Well, there are a couple of examples. Pilots calculate angles of takeoff and landing, how to turn the plane as they fly, and figure out the fuel levels of the plane. GPSs, on the other hand, use programs to find the fastest path to destination, incorporating traffic. And finally, highway authorities determine the max speed of roads based on the environment.
One of the first main areas where math modeling plays a really important role is in planes and in scheduling flight routes. There are computer systems that take in a multitude of criteria, and they have to calculate which way from one point to the next in a plane is the best one. These computers end up doing tens of thousands of calculations just to determine which are the best, either the best route or the best couple of routes. They take in things like how much fuel and how much gas is going to need to get from one area to the next, the altitudes and speeds that they fly at, and how the airplane will perform on that day, and also like the weather. And in the end, there end up being a couple of different routes that are used on the day of. Pilots can then decide which ones based on daily things like the weather conditions. Math modeling as well is not just like strict math and strict equations all the time. There are simulations that can be used, such as the one that you guys are about to see in the video. Another main area where math modeling plays an important role, and this will be one of our main focuses today, is in the subway systems and in scheduling and making layouts of train systems. The companies that are in charge of organizing these have to take into consideration many factors regarding both how the subway lines look and where the stations are located and how everything works together, because in a big city there's so many different ways that it can look, and they have to choose which one is going to be the best use of their money, the best use of time, and the most convenient for their customers. Before we actually tell you what some of these factors are, we would like you to all take 30 seconds and come up with your own list of factors. Remember, there is no wrong answer, and just think about what could possibly affect the way that a train's layout looks. Just remember as well that in math modeling, the very first step of answering the problem that you're given is figuring out what factors affect said problem and in turn will affect your answer. And in doing that, you can start to narrow down what your approach may be. Your 30 seconds starts now. Welcome back. We hope you all came up with your own list of what factors you think would affect a subway layout and a train system. And we have included some of our own ideas up on the slide, but always remember that there really is no wrong criteria. And so what you said, even if we don't have it up here, it probably is still right, and it probably is still something important that would affect a train system. So some of the things that we were thinking of regards cost and how much either trains cost or how much it takes to build. Also, what's the sort of demand? How many customers, how many train riders are in the area? Would you want to build a train station in a really bleak area or in the middle of a city that has a lot of people that are going to potentially ride the trains? As well, we thought that you would have to take into consideration speeds of trains and the different types of trains, and what are the benefits of having all these different things. And so those are kind of what we came up with. But please remember that there's no one size fits all.
So now that we've looked at some potential factors, let's look at ways that we can actually use math to put these factors together and answer today's math modeling problem. So, one approach is to use a decision matrix. A decision matrix is something you might have seen before, but if not, that's completely fine. Here, let's look at a problem where we're trying to see what fast food restaurant is the best out of Five Guys, McDonald's, and Burger King. And our three criteria are price, quality, and time. And also next to each factor, price, quality, and time, you can see a little number. So the number means the factor, how important each of those things is. So quality is ranked to 10 because obviously if you're looking for food, quality should be the number one concern. And then price is our second highest, which is out of 7, because even if the quality is great, we want to make sure that it's also affordable. And also, let's just say we're not really in that big of a rush. Time is not really a huge priority for us, so let's just give that a 3. So, using the decision matrix, we give each restaurant a score for each category. So, like for example, if you look at price, you'll see that McDonald's is the cheapest, so let's give it a 9 on a 0 to 10 scale. And then Burger King is slightly more expensive, but still quite cheap, so let's give it an 8. And then Five Guys is the most expensive, so we give it a 2. So in this case, we want to give a higher number to better restaurants in that category. And then if we look at quality, Five Guys is the best, so it's an 8, while Burger King and McDonald's are not as good, so they're a 3. And then time, Five Guys takes the longest, so that is why it's such a low number, but Burger King and McDonald's are faster, so that's why they're higher. And so total, you can see the numbers on the right. Basically, how we calculate these numbers is we multiply the ranking. So for example, Burger King in price is 8 by the weighting, so 8 times 7. And then you add all the multiplications of weightings and scores across all the categories to get a final score. And so whatever restaurant has the highest score is what we consider to be the best. Now, there are some flaws with that, so let's actually look at another approach. So another approach is using actual mathematical formulas to calculate a score or another value to determine how good or how bad a specific location is. So, let's say we're using the same example. We have fast food restaurants. Let's try to calculate scores of if we should buy food from this restaurant or not. So let's say the score is how good the food is divided by the price. You can have as many factors as you want or as few factors as you want. This, in our case, this makes sense because you want a high score. If the food is good, then the score will be higher. If the price is high, because of how division works and the price is in the denominator, then if the price is higher, then the score will be lower. So basically, you want the best quality to price ratio. And so in your case, you will have a different problem. It won't be food. It might be something else. But you can still use a mathematical formula to solve this problem. And here's a few ways that you could find this data. So, for example, for this food restaurant example, we can figure out how good the food is by looking at reviews online. So let's say Five Guys has a 4.7 and McDonald's has a 3.2. We can use that as a number for how good the food is. And then perhaps for the price, we can look at the menu for each restaurant and see what is the average price of items. And so let's say the average price of items at Five Guys is $6 and at McDonald's is $4. So then you multiply 4.7 by 6 and 3.3, whatever the number I said before, by 4, and then see whichever score is higher. And whichever score is higher is the one that we determine to be better. Now, that being said, in real life, math modeling usually isn't that simple. It's not usually a formula that you can plug in and then you'll have an answer right away. There's going to be a bunch of different factors. And so for this transportation problem that we mentioned earlier, there are a bunch of different future directions that once you do more with math modeling, you can start to approach. So, for example, over a long period of time, railways may add more railway lines, and so that can complicate a schedule. So, for example, if you had five stations at the beginning, you might make a schedule for that, but as you add more, you have to think about how your schedule would change as you add more stations. And then you also need to look at how adding any stations could impact timing, passenger movement, and the overall reliability of those trains, which can also be quantified, but that isn't something that we're covering today. And you can also look at other constraints like loops on the trail or track, platform length, station connections. Those have small or large impacts on our math models and are some things that math modelers actually look into. So when you're doing your math modeling question, you'll have to take into consideration what ifs. Like, what if something happens and how does my model account for that? Now, obviously, you don't need to go too complicated, but for your math modeling problem to be to have an effective solution, you want to make sure that you cover those what ifs. So now that we've gone over math modeling and how it can be applied to transportation, there will be a transportation question posted on the Touch Tomorrow website, which should be available for you to see now. And just as a reminder, the top 3 submissions from each day, so the top 3 submissions from today, will be recognized and will receive an award at the end of this process. So thank you all so much, and if you have any questions, please contact us at mmmjam.team@gmail.com if you have any questions.